Greetings and salutations. This is Dr. Lucien. I've created a new video to assist you with your loss run data analysis project, which is going to focus primarily on the mechanics. So I'm going to try to provide you with a step-by-step demonstration with tips that I've learned and maybe some recommendations that can help you out, because the other video set really focuses more on the concepts of each step and what they mean. So without further ado, I've created several documents to help you out, and let's get into those right away. So the first is the assistance document. It originally was meant just for the cipher in order to create the new cause, but as you can see here, I'm going to try to provide you with some additional information. Try to make this a little bit bigger. There we go. So this first one under the master, we don't mess with the master, so it's attempting to tell you what to do. I've also begun to list the macros, the functions, the tricks, and the graphs. So this is going to be a work in progress for future semesters, but let's get on with it. So the first step is to define the scope and context of the data set. And so this table right here, which is this is the first thing you do. You copy and paste over the master, and we begin by creating unique identifiers. So we insert a column, like this, insert a column, and then we number it off, 1, 2, 3, all the way up to the total number. One, it makes it easier when we do pivot tables later. Second, it gives us an accurate count because we need to express that here in this N, the number of claims. Next is we need to create a year because we have the date of injury, but we need to create something that encompasses a 365-day period. And for our data set, we use fiscal year because it started in April. So we'll go April 1st through March 31st. In other data sets, what I've done is it starts in July. And so I'll go July 1st to June 30th. If I had one that started in October, I would go October 1st to September, whatever September goes up to. And I would just then go in and manually code those. The next thing we want to do is create a total paid, because it gives us the individual benefits that have been paid. So again, we insert a column, call it total paid if we want, and then we add up the individual benefit payments to have a total paid. And for most cases, it's paid medical, paid indemnity, paid LAE, and then finally we have a total paid. And that's going to be a significant variable that we're creating. The last thing we want to do is if we don't have an open and closed, which is a claim status, we go ahead and create that. That's been a little bit tricky for people because I created an equation which was equal if, and if the total paid amount for that claim is equal to the total incurred amount for that claim, that means it's closed because they have no reserves set aside. If there's reserves set aside, then it's still open. So it's equal if, in parentheses, click on the total paid cell, click on the total paid, the total incurred, comma, quotation marks, closed. And if it's not that, then quotation marks, open. And then I just drag that down, and then I've got a new variable for each claim. And then at the bottom, we add that stuff up. It's good to have this. This is the information we're going to be expressing in the first few lines of the executive summary and definitely in the introduction of the technical report. Next is to look at the distribution. The question is, what is the quality of the data, or how is our data? And the distribution allows us to see where a majority of the claims lie. In this case, we don't we don't put on our graph the $0 claims. In this data set, there happened to be 120, which was about 7.9%. If you're interested, this is I'm going to be sharing with you results from, I believe it's Company B, and I'll be also posting this. So this was the descriptives. You see I put the dates that were here. I use fiscal years, and I've got all the information. And then the distributions here. So, but I've inserted it into the assist. And what I put here is try to give you some explanation along with how to do it. So as you can see, I've got the median, and you want to point out where the median is, where the average is. It shows, what the effect of both $0 claims and outliers may be contributing. We continue this discussion when it comes to investigating outliers, in which we sort the data set by total paid, high to low, and we graph it on a vertical bar chart. And as you can see, what I've indicated here these are all potentially natural breaks in the data. So showing where, there are really expensive claims, and then it goes down, 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 down. And so what we need to do is choose where we want to remove, cut and paste down below the more expensive claims so that we get a more natural declination here. It looks like here I probably could have said, anything under 25,000, but for whatever reason I left where it is. So when we compare the two, so we're down to 1471 from 1522, and you can see the difference. So I'm at about 46% of the original. So the original was 6.3 million. I'm down to 2.9 million. You can see how the max claim had a 3.26% influence on the total paid, and now that's gone down to under 1. So I believe that's probably where I stopped it. So now the max claim is about 27,000, and you can see how the open claims and closed claims changed. So we now have a very definitive set of results that helps us define the quality of the data and why we decided to remove outliers and how it influenced. We had originally the average was 4,144. The median was a little over 600. Now the average is just under 2,000. The median went down a little bit as well, down to 584. The closer the average and the median, the better, the data represents something that we can use statistics for, moving towards normality. Of course, we don't have that. It's asymptotic, but at least it's a little bit better. It's a little bit easier to use, work with, and averages then are more conservative. The next step is, how is the safety program performing? This is an important step because all we've really done is define what the data set represents, looks like from a descriptive statistics perspective, and how certain expensive claims are influencing, how $0 claims are influencing. And here I've got both pre and post removal. So so if you're going to do it with outliers and without outliers, it's just to compare how it might affect, how it influences. And visually, you see here the y-axis goes up to 250. Here it only goes to 200. So this is a tighter, more specific, concise look. Also, I've got the percent of open claims for the years, because when it gets higher, we don't really necessarily want to use it because they're still immature, they're still green, and so they're going to continue to increase the total paid here. Now, for our data set, if the total paid for a green year is above the previous years of the averages, we may as well include it then. But in this case, it's lower. It's going to get higher later. So let's not include it in our trending, which is why I only went up to 2017 here, because otherwise it would go down, and that would bring the trend line down. And so the R square, that is representative of how close the individual data points are to the trend line. How well it's sort of a fit. It's a fit type statistic. You don't have to worry about it specifically. I like to look at it just to see how removing outliers influences it. That's about it. And so this gives us an indication. We'll be doing this later on. This is the full data set with and without outliers. But as we narrow to our priorities from policy class code, accident source, and or new cause, this will allow us to forecast for a specific job title, for a specific cause, which is much more concise. And looking at the results, I did the outliers, and then I did the trending, and here's the trending. So you'll be able to look at this too to see what the entries are. And as you can see, whenever I do any sort of data table, I try to put the column letter over the top, because then I can verify by clicking on it and making sure that I'm collecting or calculating the results from the correct place. So always check your work. I should have pointed that out. Always check your work when you go from one tab to the other. So as I copy this over to the next one to do my policy class code analyses, I always want to make sure that I have the totals that I'm expecting to have. And so that's why I try to keep previous results tables available, so I can always check my work. That's what you should be doing. The next is a policy class code. This is from the you can refer to this to see what the actual equations are. And as you can see, I've got the column. You can see where the column goes from. So you could actually search around. You should be able to reverse engineer your own work by me providing company B results. But let's go back to the assistance document for the where. So I tried to put in here the functions used and what the equations look like. Try to give you more explanation. For this one, they had a lot more policy class codes than we had in ours. But then also, I try to give an example of how to check your work, and that is comparing the totals from your results table to a previously created table. And as you can see, I try to draw the lines. There's a lot of lines here, but if any of you have joined me for office hours, this is something I always check. Another thing I do to check your work is I click on a particular cell to see what you have entered, just to make sure it's correct. That's how I grade. That's how I what was I going to say? I was going to say trouble check, but the word, the phrase is eluding me. And then I've also got some recommendations. It'll always be check your work, but if you have a missing entry for policy class code, use pivot table to see what the list is. Something missing, you put in a dummy code, 9999. If there is already a 9999, you make something else up. It could be even a word if you really wanted to, but I like to keep it in the number family. And then, so then you do the Pareto analyses, top 2, top 3, top 4. I could go 5, 6, 7. I could go all the way up. But then what we're looking for is that 80%. And so it falls in between the top 3 and top 4, which is between, 18.8 to 25% of the policy class code categories. That's what the Pareto ratio is, the 80-20. So 20% represents 80% of here, 80% of that. Okay. And we also have the risk priority number. I talk about, risk is equal to probability times severity. Our risk priority number is percent count multiplied by percent total paid for each individual policy class code entry. And then we prioritize. We sort the results table by RPN, high to low, and then we just go 1, 2, 3, 4, 5, and then it's really easy to add these up. Add this and this, or sum this and this, and then the 3 and the 4, and that gives us our priority given the current data set. And I believe in this one, yes, we have outliers removed. Next is to focus on the first level of cause, or how people got hurt. We use accident source. It is and I don't know if you notice this, but it's the exact same header row. So the technique for analyzing this is exactly the same. And if you've been on some of the office hours, if I place this table right above the previous one, so I go and insert a bunch of space and put it right above, I can actually copy and paste the equations that I used for the previous table, and then I just have to change the columns that represented it. And that's having been, when you freeze certain ranges using $signs, you can do it that way, and it's super quick. So once you've populated this, and I don't know if I put that they use pivot tables. I use pivot tables to populate this. Didn't see any openings or missing information, which is good. Once I've entered in all the data, sort by RPN high to low, and I put in my priorities. I do my Pareto analysis. Here I did it by 5s. I popped in a 12 there. And as you can see, I've got between 78 and 86 here. I've got close to 80 here. I'm representing a large portion, 30 to 38. So I believe this is justification for creating a new cause category. The cipher here, the way we use this is that I've got 4 different examples of what previous data sets had for accident source. And so what we can do is we can look at our data. We look at our data, and we, making sure I go to the right one, go to the new cause. And up here at top here, so we've got our accident source. So I would highlight this, I would do the data and the filter, and I would sort by my accident source. I would insert a column and call it new cause. And then, so then what I do is I go through, and so for my first, alphabetically, my first cause for accident source was allergic reaction. Then what I do is I would go to my cipher and see allergic reaction was in all 4 of them, and it was purple. So what I do then is click on the new cause category, purple, which is exposure to chemicals or biological agents, sort of a parent title of a cause for allergic reaction. I do the copy, which I use Control C to copy, and then I would then paste it in the new cause, and it's already here. And so since I have a bunch of them, then I would do the copy paste, which is put the cursor over the bottom right hand corner of the cell. It changes the cursor, and then I would just drag it down to cover everything. Go to the next one. It says bitten by animal. I go back to cipher. Where's bitten by animal? I got them all here. It's red. So I go to violence or attack by animal or insect or human. I do the copy. I go back to mine, paste it, click it, drag it down, and I've got all those covered. Same with caught in between. I go back to the cipher. I find it in one of these 4. It looks like it's this brown one. I copy caught in or in between. Copy that. Go back to my... Oops, sorry. Go back to my... hit paste. Click and drag it down. And I do that for the entire data set until I get all the way to the bottom. Now I have the outliers up here because they need to be recoded as well. And then I come down here and I recreate this table. It's the same table, same equation as for the policy class code, for the accident source. It's the same thing, but I've got a different column. I've got different categories within that column, and I'm counting percent count, the paids, the percent paid, the average pay, RPN, and priorities. And again, I am looking for the Pareto ratio. And here I got it between 3 and 4. Actually, yeah, because there was fewer things here. So between 3 and 4, go back to the example and go to the new cause. You see, I actually put these on top of each other just to show you. I guess I didn't include the policy class, but it could be there. It could totally be there. Again, I'm just trying to prioritize, and I do it with and without outliers, see if these priorities change. And actually they did for our analyses. I'll bring ours over. I got the trending base here, but if I go to the new cause stuff, so for with the original data set, slip, trip, fall was number 1, overexertion was 2, struck by against was 3, caught in between was 4. But when I removed 28 outliers, overexertion became number 1, slip, trip, fall became number 2, struck by against 3, and then caught in between still stayed 4. When I removed 59, overexertion's first, struck by and against became number 2, slip, trip, and fall became number 3, and then the caught in between became number 4. Now I'm going to analyze all 4 of these no matter what. And you can also look at the magnitude of the difference here. It's interesting, even though we're doing rank order here. See, I could possibly look into miscellaneous. The Pareto ratio says that I don't have to, but I could. But as you can see, look at the magnitude of the difference here. 74 to 61, that's not too much of a difference. But 184 to 75, that's really going to start, minimizing what we can forecast, because that's several years. So if we can only say, this is cost about $5,000 per year, I'm asking for $4,000. That's, it's minimal. We got to at some point stop and just focus what's going on. Let's go back to the assistance document. So now that we have the new cause, we start forecasting. And what I recommend we do is we bring over the most recent tab, which is the new cause. So everything's coded as a new cause, and we do it with and without outliers. Here what I have is the outliers are included, and I've sorted by policy class code and then deleted everything that is not 8833. So in the example of company B, get up here to, so I've got just 8833. So I sorted by policy class code and then went over here and highlighted certain rows and then deleted it if it wasn't 8833. So I've got just 8833 here. And by doing it that way, all the tables, the results tables that I made previously, they all updated automatically. So look, I've only got 8833. My count is 568. I've got the total amounts here. I do need to go down below and delete all the non-8833 outliers as well. And I'm going to trend this. So just for 8833, here are my priorities for the new cause. And so then I go ahead and trend it. I take an average, an annual average. So I've got the totals here, got the annual average, and I started creating this this table here that combines average from tables and then the figures forecasting. And so by creating it here and copying and pasting it as I start narrowing, all I have to do is update where it's pulling its information from, and a lot of things get easier. So like for open claims, it's actually clicked onto one of the previous, I'm going to double click on it so you can see it. So it's always been updating the open claims. It just brings it over. Hit return so it doesn't screw with it. Here I've got the zero count. And so it's just an honest reporting of what's going on. It's got the median right here. Now for the trend lines, what I'm doing is I'm doing scatter plot, just like we did earlier, but this is a condensed or a more precise data set. I've got the count, I've got the total paid, I've got the average paid. We extend the same sort of theory on the percent open claims, whether we use, which years we use for trending. So we don't want to put a year in that's incomplete. We don't want to put a year in that there's open claims and the total paid is lower than the previous. And so as you can see, I've got my trends here, and I put these answers. So I'm extending up to 2020 for count. It's in between 70 and 80. I'll probably put in 70, 73, 75, whatever it is. For the total paid, it's right around 150. That's what I put. For the average, it's right around, it's between 2,000 and 2,500. I put in 23. I could put in 2,250, whatever. Then what I do is I take the averages. Be really careful here. A lot of students add it all up and then put it in. If I was to do that, it'd be 1 million. That's something I usually look for. It's, about 106,000 total. Oh, that should be 106,000. 106,474. I take the lower of the two, and then you can round. This could be 106. This could be 107. Again, it's just to try to get to something. Take the return on investment. It says 25%. The equation is I don't know if you can see it up in the upper left-hand corner, but you can definitely look this up because this will be available. It's the quantity of the estimated loss divided by 1 plus the return on investment, because that's what the equation works out to. So we have an estimated requested investment based on these other two numbers that we came up with. I then go down and I mine out the number of outliers, the total, the average. You can look and see how many are open if you want. It just means it's going to keep going up. And I've got this other information. So this is a more honest reporting of a much broader data set, just focused on one particular policy class code. Now, as we start reducing it and just looking at individual causes, these numbers are all going to go down because we're looking at fewer claims, but it's a more precise recommendation. It's a more precise investigation of what's going on. Let's go back to the assistance document. So by setting this up, though, for something broader, like just the policy class code, now as I investigate the new causes, which are prioritized where? Here. So the first thing I'm going to look at, because it's number 1 here, is slip, trip, and fall. Then I'm going to bring this over, and I'm just going to look at overexertion, patient-related, overexertion, all that stuff, okay? It just makes it easier. And then I'm going to recreate this for my next policy class code, which is 9040, and I'm going to do the same individual steps and creating this results table. And I showed here that there are 2 ways to look at it. And one thing I've been doing is changing it from years reported to average per outlier. I think that's a better representation. And what you do is just divide the total by the number of outliers. There you go. If I had a thing, I would take out the pennies. I always take out the pennies. We shouldn't even be concerned about the dollars. Everything should be rounded to $1,000 or $500 at the least. Okay? And I've got other description of what you can do up here. But again, you can go into the example, the company B example, and click on cells to see what I use for equations. And by double clicking on it, it shows the ranges that I used, or the cells that I clicked on. Let's see, there, you can see it's total paid. Hit return so I don't screw that up. All right, next is, so I showed it, I actually did a copy paste as a picture, which is a new thing I just found out today. Makes it easier. We don't have to use portals as much, but this, you're really only going to use this for data entry. So here I've got policy class code 8833, just the slip, trip, and fall. And then you can see the full results here is I've got the counts, the totals, the average. I entered them in to the table here. Actually, I did it automatically. So for table, I did integer and clicked on that cell. For cost, I just clicked on that cell. For forecasted, I just clicked right there. Actually, that's different. It should have been clicked. Do as I say, not as I do. And then I got the figures, and so I had forecasted them out and put those numbers in. Take the lower of the two, got that number. Manually enter this stuff from the outliers down below. Always remember to make sure you clear those. I think I have it down here. I have just slip, trip, and fall, just 8833. And so it's a very focused analysis and results. The last thing we do is we bring over these tables. So I took a picture and put it right here, and then I manually entered them into the final results table. And what's interesting, what I like, is that we're reporting very honestly these individual priorities. So priority number 1, this policy class code, this cost code. You can sort this based on what is the requested investment, or what is the estimated loss. That's what I would do, because again, it's the highest priority would probably give us the most bang for our buck, get the most back. We're also reporting the median, we're reporting ranges, we're reporting outliers removed. About the only thing that isn't here is the number of percent open claims, or the $0 claims, which we've got it here. We could put it in if we want. It's just I wanted to fit this on a page. It's a more honest reporting based on everything we learned. And then what we get down to is the total or average. I put that in there because you can't like sum up at individual averages. It has to take the average based on what's there. But most important is the total requested investment, the total return on investment. If it varies, from 25%, the total or average, outliers and claims here that will show that invest this amount of money on doing more in-depth studies of what into these policy class codes and the causes of these injuries. And if we can get to the root cause and eliminate it, this money would be invested into both the investigation and what the solutions would be. We can show you this amount return on investment. And then it doesn't include these outliers, because usually one outlier is more than what we're even requesting. Prevent one of these, of which there were 8 over the time period, and you're going to get your money back. And so it's a very safe, I should say conservative or safe investment. And we're using numbers and graphs, all kinds of stuff, and conservative estimations in order to get these numbers. So in this case, there are 10 in our case for the class. And I want to show you something that I discovered. So here's our data. I referred to it earlier when I was comparing the changing of the rankings based on how many outliers were removed. So the trending base, here we have 16% of our open claims are in fiscal year 2018. However, when you look at the total paid, it's 1.47 million. That is the highest number. That's going to keep going up, in which case that means let's use 2018. But let's look at it when we take out trending with outlier. I should have all 59. I'll get back to that. But so it goes down to 13 here, and the total paid is still the highest. So originally I was telling you guys not to use fiscal year 2018 for trending the total paid and the average, but based on this realization, I think you should, because it's just going to get better. The trend line is going to keep going up, or the numbers are going to go up. So it's a low estimate. Therefore, let's include it. Just want to point that out to everybody. The next thing I want to do is what I did here is I did the what I have on the screen is what I had just described to you. So this is only policy class code 2220, and it's the original, so there are no outliers removed. So if we look at so I did the trending here, and I've got these estimations. So 0 outliers here. So this is as high as it could possibly get for all these estimations. Oh, and I even did it through 17. So here's how I change that. I click on one data point, and you see it's now highlighted what's here. And what I'm going to do is just extend it out to 18, and look, it already did it. So, but the total paid came down on this one. So, there it is right there. So it actually came down. So it made things actually worse. Isn't that interesting? And how many open claims do we have? We've got, where's the open claim? Count, 31. So it is going to go up. So this is a conservative look. I should probably do it for this as well. Click on the cell, go up. Yeah, I got to click on it again. Click. And extend it by 1. It's going to bring it down a little bit. Yeah. But here's something I've been thinking about, and I hope you agree with me. I mean, the whole reason for this project is to have you really think of the problem, not just mimic the steps to get numbers and then attempt to, make guesses on what it means. What I really want you to do is to think about it. And what I'm thinking about as I look at here is we've got 3 years of almost zeros. And by anchoring it at the beginning, it's going to make the slope go up. So what happens? Let's see if then we've got all the numbers still the same. Still 120, still about, the total paid is about, it's about 1 million. Okay, let's put in 1 million. Went down when I added 2018. And what did the average go down to? It's about 13. Okay, well, put that in there. So here's what I want to do now. I want to see what happens if we take out the 0 years, because that's actually causing it to, I'm actually going to take out that year too. So we have less years in our analyses, but we've taken out the bottom, okay? I'm going to do it for each one, and then I'm going to come back and explore it. I just think that if we're going to analyze $0 claims and consider their influence, or actually the more expensive claims, shouldn't we also do it for when it's almost nothing? And this is going to make it more conservative. It's going to make the trend line go down. The estimations for future losses is going to go down. But again, I want it to be more honest. So let's look at it now and see what we would have. 2020, the number is now probably more likely right around 105. Look at that. Okay. Now, did it dip below the annual averages, which was what we were going to use? No, it didn't. Total paid. What happened here? It dipped down to right around, I'm going to say 950. Is that safe? I'm going to go, yeah. Oh, that was supposed to be a million, sorry. I'm going to say 950,000. One under a million. How about the average? The average is just below, so I'd say 9,500. Oh, shoot, I was supposed to do it on the side. I'm sorry, everybody. So these numbers came down, but did it change what our estimates are? No, it didn't. So I did it for that one. Now, if we were to move it over, and I remove the outliers. How do I remove the outliers? Well, I've done it so that I've numbered my outliers outside of the original set. Sorry, everybody. This thing moves really fast. I know this video is long. So look at here. So when I originally had removed them a long time ago, I gave them numbers. So this is the 4th most expensive. That's the 38th, 47th. And then there's some down here. They're under the slip, trip, and fall. So if I sort by total paid, high to low, you see how they all lined up now? So all I have to do now is highlight. First of all, I'd copy and paste this whole thing over to the new tab. And then I would cut and paste these down below. And what that did, that's how I got this whole table. That's how I got this whole tab updated. And then, what I needed to do is just make sure that the data came from this new table and not the last one. If it did come from the last one, both these tabs would be highlighted. And then I would need to make sure it came from my tab. Looking here, see, we're still counting the zeros. Let's see what happens when we take these out. I'm going to take out 11, 20. So it's only 14 through 18. Did that change my estimation? Now I'm about 92 or 93. Yeah, it did. So what I could do is do the figure, put in the years that it counts for, and then the years, the different changes. I'm just trying to get a more honest representation. Okay, so I clicked on that. Oh, click on it again. Take out 2 extra years and actually put in 18. I guess I hadn't done that yet. And let's see where it went. So it used to be 200,000. Now it's 180,000. Oh, no, it's more right here. It's more like 160,000 probably. It's more conservative. That's okay. It's a little bit lower. The ask is going to be lower, but we're more likely to achieve beyond the estimated return on investment if we're more conservative. Oops. Okay, click this again. This can be very sensitive at times. Okay, so we got 14 through 18. It's 5 years. The new estimate is right around, I'd say 1,800. What was it? See, it went down a lot. Did it change what we used? Well, the lower of the two was still 63,000. But you see, we're being a little bit more conservative. It flattens the line more. It makes it more horizontal than it did. And I think that is a more conservative, better estimate. So I'm going to be changing all of my estimations to the 2014 to 2018. You don't have to. You can move forward. But if you were thinking about it and what it represents, again, if zeros were on this end and we took them out, it would bring it up. Is that honest? Well, no. It's increasing something. So look at here. I'll do this with the count again. So that already went up to 18. I'm going to bring it down to, we were doing 2014 before. How much did it change? 2020 is still about 23. It was 22 before. It didn't change it much. Let's try the total paid. Bring it down to 14. This one is already set to 18. I must have figured that out. The new total paid is about 73, 75. It has actually gone up. Interesting. That will happen once in a while. But again, the average annual seems to be a little bit lower for whatever reason. So that's what we're using. So they're more conservative estimates, not including outliers. See, I have the average in here instead of the number of years. I think this is better. I mean, we're talking smaller numbers. We're focusing on the less expensive claims. But still, this is when we're bringing back and considering the expensive claims that have been removed, that we took out because it was more conservative. Yeah? Here, I'll do average too and see what that does. Just took out a couple of years because they were zeros. Makes it more conservative. What are we at now? About 4,700. Where are we? It went up. It went up on all these. However, I know that there was one in which everything went down. Look at that. So it started going down. So how did this change? Well, the total paid at 2020 is 0. But let's look at we've got outliers that represent over 225,000. There's only 3 of them. The average is 75. So instead of using 0 and instead of using the annual average of 13 or 14, I went and put in 10. I think it's justified based on what we have here for outliers. I also look and see how many years here was it above 2010. And 4 of the 5 were. Then the 5th was right here. So I think just looking at this, comparing what's here, I think 10,000 is a number I can justify, even though everything's going down. I mean, if it was 0 for the last 3 years, yeah, I probably couldn't include it. Whatever they're doing seems to be working. But there are still counts here, and we took out the first few years because they were zeros. So indication is there's going to be some in the future. I'm saying there's probably going to be around 4 or 5, and it's going to be about 10 grand. So that's what I'm using for my estimation. And then I got the 8032 base. And then the final recommendations, I copied and pasted what I'd figured out here, manually entered it. And again, I'm going to do it for anywhere from, 5 to 10 individual, and then I'm going to have my totals. And that's really what we're working toward. So back to so this is the help. No, that's the answers. Duh. Here's the assistance document. It looks the same. I brought over an individual so you can see how it worked. And then to the results for company B, you'll be able to access this and reverse engineer. As you can see, again, this is a different data set, but you can see what it looks like at the end. A much more honest, comprehensive, and detailed review of the company's workers' compensation claim payment history. How that's going to lead to potential future losses, and how investment and deep investigation, root cause analyses could save the company considerable amount of money. Yeah. So I hope this helped. You have several more resources now to help you along to answer your own questions, but I do hope that you take the time to really understand this from the perspective of you're asking your own questions, and you're able to manipulate, whether it's sort and add things up or divide by things, in order to answer some of your own questions, because that's what this is all about, is to have you really build up your problem-solving brain power, if you will. Because that's what this career is all about, is identifying and solving problems. And so this technique keeps evolving over time, and I do make decisions, like I just shown you in this video, to make things a little bit more conservative, a little bit clearer. And I'll be finishing up, I believe, this semester's analysis here very, very soon. But if you need to talk to me, please reach out to me. That's part of the active learning that this course is built on, that try to figure it out on your own, but when you can't, reach out to me. And when you do reach out to me, please don't use language such as, I'm totally lost, I'm totally confused, you went too fast. What that does is, if you were to use that in a job, what would your boss think of you if that's your response, or how you'd ask for help? What I want you to do is say, well, this is where I'm in the analysis. This is a bit confusing. This is what I think it is, but could we discuss it so that I can move forward? And then we can set up either a phone call or a WebEx, and we can work through your issues. Also, then it doesn't perceive that you're blaming me, or you say you're blaming management for you not being able to finish, a project or a task on time. It's better to be transparent and open, but honest, just like this project is trying to teach you with loss run data. So with that, I'm going to end it. But again, reach out to me. Please try to take my tips with how you word, how you want help, or where you are. And hopefully you're getting to resolution on this project really soon, so then we can focus on the best way to present what the results are.